Hello, everyone. Welcome to this fifth version of the dialogue series on data sharing and data management principles by the Group on Earth Observations Data Working Group. I'm Bente Liabi. I'm one of the two co-hosts. With me is also Marie-Françoise Wadreau from OGC, and there she is. We are sharing this hosting sessions among us, but all of you who have been here several times and also all the speakers knows that we are working as a team. Now, today, I will also start in the regular way to introduce you very quickly to what the dialogue series is, and also to the principles, and before we start the program. So I will share my screen. So some house rules. First, if you are not speaking, please remember to mute yourself, the microphone. When you want to intervene, please raise your hand, and we encourage both of this, by the way, in between, because this is after all a dialogue series. Write in the chat and raise your hand, and we will give you the floor at the right moment. Other than that, enjoy this dialogue series. So a little bit about the background, why we are having these dialogue series. It's simply because we wanted to advocate the geodata sharing and data management principles. Many of the members of the community, the Earth observation communities, might have heard about them, but are not quite familiar with them. So we wanted to advocate them, particularly for the GeoWork program. We wanted to create awareness, and also, so that's part of advocacy, you could say. We wanted to create awareness about the benefits and also some of the challenges that you might meet if you are about to implement the geodata sharing and data management principles. But first and foremost, we want to make you aware of the advantages. We also wanted to create sustainable resources so that we are not only doing this once, we are not just creating a document that goes into the archives. We wanted to create material that will be there for you to revisit. So we will put this material, we record all the dialogue series, we will put the material, the presentations, and etc. on the Geo Knowledge Hub that you will learn more about, particularly today, but also share the material in the social media. And why do we want to do this particularly now? Well, we have reiterated our efforts on in situ data. It's not a new thing in geo, but it seems to be forgotten. And right now we have very much focus on making in situ data easier to use and create some attentions, particularly to streamline also the in situ data along with the space-based. And for creating applications and services, it's also necessary to look closer to law, regulations, and licenses, etc. So that's why, why we are doing this now. And here you see that we are looking at the data sharing and data principles with these eyes, so in situ, law, and policy. And we want also to highlight how we have implemented this in the GeoWork program, so the activities in the GeoWork program. And the structure of all the dialogue series is that we present the theory or the principle, if you like. We provide some examples on how they are being used. And if relevant and when relevant, we try to compare it with fair, care, and trust, other data sharing and data management principles. So that's the structure. We have arrived now at the fifth version of the dialogue series. We have today we are going to talk about usability, and there are four so-called data management principles in usability that Joan Masso will show to us. And here is a reminder of the data sharing principles. I will not spend time on this. These slides will be provided to you so that you can enjoy them and be reminded. It's we are famous in Geo for, I would have to say famous, it's one of our great results to promote open data sharing. So that's why we want to promote that as well. And here are the data management principles. We have squared out the usability. I will leave the floor to Joan to actually introduce them, so I don't have to read them up, but you see them in the context of the other data management principles. It's encoding, documentation, provenance, and quality control. And we will dive into that. Marie-Françoise Roidreau, as I said, she works in OGC, the Open Geospatial Consortium, and is together with me co-hosting this dialogue series. She's deeply involved in all things Earth observations. She was contributing to the Next Geos Horizon 2020 project, currently engaged in the eShape project, and also contributing in many other ways. She has a substantial experience from Météo France, close to 30 years, I think. So, and she is award-winning. We have actually two OGC Gardel award-winning persons here in this room today, namely Joan and Marie-Françoise. It had to be said. So, and me, I run currently a small research and consultancy company, but I have been involved in Geo with other hats since 2004. So actually in the formation years of Geo, I have been working with many different aspects of Earth observations, all from applications in climate change, in geohazards, but my remaining baby is interoperability of Earth observations, and that's why I'm spending time here with you today on promoting data sharing and data management principles. So again, the chat, use the chat. We would love to hear from you, and we will also run, as per usual, a poll, very simple polls, so that you can give us some feedback, and maybe we can, based on your feedback, we will be able to have some interesting follow-up questions. That has been the experience up until now anyways. So please participate in the polls, and by all means raise your hands and use the chat. So usability today. Well, yeah, here is the program we have done now with the introduction. Joan will give us the theoretical introduction to the 4 principles for usability. Then we are looking at some examples from ILTER, ensuring reusability of data from ILTER long-term ecosystem observations by Johannes, sorry. From the, I will introduce you later, Johannes. And then the Geo Knowledge Hub, making data and services more reusable. We have an example from GeoGlam, and we also have an example from a remote area, from from cold region, sitting up late today from Yubao Jiu in China. So, Joan, he has been working on interoperability and standards for a very long time. He is a principal investigator in CREAF. He has been, I already mentioned that he is award-winning Gardel award in OGC, and you can see that he has been super active in many different EU projects, all related to use, facilitating the use of Earth observations. I hope you agree with me on this short version of your bio, Joan. And that's of course because of this strong background for this. He is a perfect person to introduce us to the theoretical part of the usability data management principles. Joan, it's a pleasure to give you the floor.
Thank you for the introduction. I would like to talk a little bit about the data management principles related to usability, and they are 4 of them. First, let me give you a context, and this is a dialogue series. We dealt with this discoverability before, we dealt with accessibility, and now we are dealing with the usability pack. So this effort in this dialogue series is partially originated by this revised geodata sharing and data management principle effort that has been done, and we are proud of sharing that with you. When we talk about usability, we are talking about data encoding, data documentation, data traceability, and data quality control. Those are the data management principles number 3, 4, 5, and 6. For data encoding, the principle says, the sentence that introduces the principle says that you should do it in a structured way. It could be widely acceptable, should be widely acceptable in the target user communities. And if you are able to do it in an open international standard, then even better. For the data documentation, we focus here on the comprehensive, the comprehensive word that means as complete as possible. So elements for access, for use, for understanding, and for processing the information are requested. They could be served in structured metadata that is easy for machines to consume, but could also be exposed in peer review documentation and these journals about data that these days are becoming popular. Data traceability, it's all about provenance and metadata provenance in particular, talking about the origins and the processing history. And this is to know and ensure the reproducibility of the product chain. And finally, the data quality control says that it's important that if you do data quality, please, you should include that into the metadata. And if you haven't done that yet, then it's advisable to actually flag your data as unchecked. So talking specifically about data management principle number 3, data encoding, we can say that we are talking about data formats with defined data structure, but also more recently, these data memory structures that you can retrieve from services directly, independent from the format. No. So we are not talking about PDFs. That's what we mean by that. They enable syntactic interoperability, so it's important to use well-known formats for the community, but I believe it's also important to use common formats that are easy to use in any GIS by the community at large. But we are also sensible to the semantics part. So we need to know the concepts that are described in the data set, the variables, measures, the units of measures, all this stuff needs to be also encoded somehow. And apologies if you like CSV, but you know that the common use of the CSV is precisely to have these columns with these weird titles that nobody knows exactly what they mean. Well-known formats for thematic community, many of them are available. Here some few examples, common formats that are becoming popular these days, the GeoJSON, the GeoTIFF, or the cloud optimized GeoTIFF, or the GML to exchange feature data. About describing the concepts, not all the formats are particularly good at that, and the observations and measurement models or the WaterML specialization are 2 examples that do a special emphasis on that. And on data memory structures, we are assisting to this Python XArray popularity these days due to the data cubes and the transcription into or serialization into formats, that is the ZAR approach. This is about data encoding. The data management principle number 4 talks about documentation. And in documentation, we mean metadata, but beyond discovery. So we need to describe the access, the intent of use, the CRS, the format, the meaning of the data, its structure, the dimensions, the fields, the bands, if it's 3D or 4D, the special partition in sheets, the time partition in time series, the update frequency, and the latency, the timeliness, whatever. Examples of those well described metadata models, we can find them in the ISO 19 series. I will not go into there. Dublin course, Darwin course, stack, and climate and forecast metadata conventions, the CF conventions in particular. Going to the data management principle number 5 about traceability, we are still on metadata because we are talking about lineage, provenance, and reproducibility. The metadata should capture the sources, the processes, the parameters used in those processes, the chaining, how the processing chain was done, producers involved in sources and in processes, links to tools, algorithm descriptions, whatever it's available that will secure the reproducibility of the same product if we really need it afterwards. So, and that's complicated to capture. There are automatic tools embedded in the production workflow. That's probably the preferable way, but of course we can also do it manually. And again, in metadata, we can talk about data quality in data management principle number 6. Of course, we have to do quality control and quality validation, and the procedures depends deeply on the product and the processing chain, but we also need to try and document it the best possible way. And why? Well, that's because actually the best quality product might not be the better for your purpose. And one particular example is these common classification algorithms for land cover detection based on spectral classes that will fail miserably with very high resolution imagery because too much detail in that. No? So document the quality is important. We can do it as a report. This is difficult to compare with other products. We could do it as a conformity to the specifications. We could do it as numeric indicators based on standardized sets of quality measures, or maybe on uncertainty of the individual observations or pixels. So we can have quality at the product level and the data stream level and the pixel and observation level at different levels. What happens if we do not have information about data quality strictly the way I just described it? That's unfortunately quite common. Then we have alternatives like trusted data producers or trusted product workflows based on lineage and confidence to parties or to procedures. We can have peer-reviewed processed for data where those experts will validate that, and we can have trust in them in particular. We could have quality labels, for instance. We could actually ask the users what they feel about that product, no? And that's the geospatial user feedback approach about experience and reporting applications of the data and success stories or wrong stories. And also we can connect that with trusted repositories that are for sure well corrected if they follow the trust principles. So what about recommendations trying to cover everything, the capture and use of rich metadata models to populate them and share metadata records? They should contain information about as much as possible details in the different aspects of the data. I will not repeat them. Use standard formats for data as well as for metadata to prevent vendor locked-in and recognized and facilitate the recognized use of easy tools, easy to find, easy to use. Provide alternatives. So there is always this perfect format that the producer wants that is very detailed and very verbose, but it's quite difficult to understand by everybody. So apart from this one, it could be also useful to export that to popular formats that might be easy to use, even if you believe some things are not present in that format. And yeah, I don't know, topology, for instance, could be one possible example. Also, another recommendation is package your data with the metadata and with the descriptions of the meaning, vocabularies, dictionaries, and so on. So the user will have them all, and then usability will be guaranteed, at least in that aspect. So thank you for that, and I'm eager to hear about the use cases. So the people that are actually applying those data management principles in actual data sets, and how they are doing. And let me just say that this work is actually supported by the ENCAGE project funded by the European Environmental Agency.
Thank you very much, Joan. A very nice overview of these four usability principles. I'm actually attending a meeting here in Prague in the Space Week, and introducing, data management was presented as a burden. And now, would you say, even though you are working more on the theoretical side, you have implemented also, do you find it cumbersome or a burden to meet these principles?
Well, there is definitely a feeling of boredom in the community. One thing that I could say is that you really need to think about the way you are going to manage your data in advance. So what is really scary is when you get that by surprise. So you have the product all done, shiny and available there, and suddenly you do not remember the details. You start having doubts on the provenance, and you forgot about reporting the CRS, and that's because there was no sufficient planning, and maybe you were not prepared with the right tools. If you had the right tools and the enough planning in advance, I believe it's no longer a boredom.
Yeah, and just a reminder from I believe the very first of our dialogues, where we sort of gave a motivation for engaging in using this data sharing and data management principles, and is that everybody is asked to make a data management plan, right? So these are what we are offering now, is tools to help make these plans. So either for the practical use, and we will learn about some use cases now, but also to accommodate the requirements for those who are funding you. So just to remind us that the data management plan is what we can't, it's a smart thing to do. Anyways, I published a poll while you were speaking, Joan, and I will end the poll, and I will share the result with you before we start with the use cases. So I believe you can see the result. Most of you, or half of you, are actually using or implementing, or no, sorry, correct myself to the question. They know about the four principles. Some have heard of some of them. To some of you, it's new, and others are not quite sure. So I think that the result here is that people are aware of them at least, but now we will learn about some practical implementations of the principles. So we'll go back to sharing my screen. Here, Johannes Peterseil, we are going to hear from an example of ILTER, but Johannes, he leads a team for ecosystem research and environmental information at the Umweltbundesamt, and has been involved in ecosystem monitoring for a long time. He's a landscape ecologist by training, and he is very timely interested in fostering access to in situ data. So I think I will give you the floor there, Johannes. We are excited to hear about your experience.
Yes, thanks. So I'm going to share my my screen. So do you see it?
Yes.
Yeah, thanks for the possibility to contribute to this dialogue, geo-dialogue series here. You earlier heard on a presentation by Christoph Wohner on the DIMES system focusing on accessibility. In this time, we want to focus on usability and reusability. So basically, we changed the title a bit, but basically it's about to ensure reusability of long-term observation data from long-term ecosystem and biodiversity research. And one of the important tools where we see is also to provide the context of the observation. And this is where this tool, this DIMES SDR, comes into play. In the audience, also my colleague. Do you still see? No.
You ended the presentation mode.
Sorry. So it should be on again.
You're back.
Yeah.
Yeah.
Yeah. Also in the audience, my colleague Christoph Wohner is here. So any questions we can address both of us. So the availability of in situ data and having proper description is important. Also is important to gather knowledge about what happened in the past, what will happen in the future with ecosystems and biodiversity under the light of climate and global change. And one of the important aspects in this is also to have information on the observation context of the sites, and this is what the systems, or what DIMES SDR is about. And I will take some words on the context before focusing on the implementation of the data management principles, what we tried to take into account. So DIMES SDR is a web-based catalog for describing sites and data sets for long-term observation. And in this context, the sites is defined as a place where in situ observation or experiments take place, which is the limit in space. This can vary in size. So we have sites ranging from, let's say, a quarter of an hectare up to 1,000 square kilometers, depending on the observation context, and it has an internal organization and structure, and is used for collecting data. So that's the important part. DIMES provides information, or allows the documentation of environmental monitoring and research sites. And currently we provide data on about 1,200 sites on the global scale, where about 600 are located in Europe. And you'll see the distribution map on the right side of the screens. And basically you'll see also this global coverage. DIMES is used by research networks like the European LTR network and the upcoming ELTA research infrastructure, but also by ILTR, the International Long-Term Ecosystem Research Networks. And it's also used in a number of European scale projects like ELTA or eShape, where the system was further developed. It serves data, geodata, but not only to other services, so to be implemented for the further use. So it's one important line of information provided. In order to ensure the usability and the reusability, DIMES issues persistent and resolvable identifiers for each site, the DIMES ID, so which enables a linking between different systems and the use of this identifier. Also, for example, in metadata or in the data sets itself, 4, where we come to the data management principle on provenance, where it's important to have this contextual information. As already stated, DIMES provides information about the observed properties, geographic context, contact details, and environmental characteristics. So to have a comprehensive description of the sites, and you see an example of a landing page for a long-term observation site we manage and run in Austria, where you'll see a lot of the characteristics. All of the information is available through machine-readable endpoints. So that was one thing we developed over the last year in order to ensure this usability. Data are open, so researchers can use this kind of information, and we apply the CC BY non-commercial license to the data provided. Information is managed by the different site PIs, providing the information, doing the description, doing the update, and the service is centrally hosted in a coordination between UK CEH and the Environment Agency in Austria. The geo-management principles and how we address them, Jean already presented then and provided an overview. And basically we are addressing all 4 of them in one way or the other, but most important is the data management principle number 3, to use encoding that are widely acceptable with a preference to non-proprietary or open international standards. That the way we do it, and they come to that later on, is focusing on JSON and XML as the encoding to provide the information shared through machine-readable endpoints. We also try to foster and ensure comprehensive data documentation and information documentation, including all elements, so on access, use, and also on the content of the information in a formal metadata structure based on international or community approved standards. For the site information, we are focusing on a community standard provided or developed by the LTR and ILTR community due to missing information exactly for this part of information. But we also take into account recommendations by the observation and measurement and also the implementation of the INSPIRE environmental monitoring facility. And we are also sharing, and they come to that later, using, for example, ISO or DCAT as a ways to share the information on the meta information on the data. Data management principle 5, dealing with provenance metadata. We deal in a way that site information is an important information in the provenance chain for in situ data, which we also address in the ELTA context. But this we deal with that later on. An important part is also quality control, and I will talk about that. So in terms of data encodings, the way we implemented that is providing a REST API, sharing the information for the which is collected and provided through the DIMES system. The API is following the Open API specification, and it can be used for a number of scripts and external applications where we have, for example, to extract information on Earth observation on the tiles of Sentinel, but also providing, for example, catalogs or using this kind of information in linked in situ metadata sets. You can find more information on the DIMES documentation on that, and in terms of encoding, we are using JSON and XML as a way to share the information. Jean also mentioned semantics in that, which is important, and we use an SCOS vocabulary, EMFTES, in order to have the terms used in the metadata and ensure the reusability in that. There are a number of papers provided by Wona et al. Which describe the data models used. In terms of workflows and how we are sharing the information from the DIMES database, basically we are using GeoServer on the one side as a standard to provide standard OGC, WMS, and WFS information from the site boundaries or site locations, and the REST API to share the information, the context information which is provided in the database itself. There we have a mapping to ISO. So we provided as the community schemata we are using for the site description, but there is also an ISO mapping which is able to share the information through a CSW, but also a TCAT mapping of that. In terms of quality control, and to ensure the quality of data we have, we implemented a quality assurance tool for the site records, which is available to all users to have a statistics on the quality. And we used a gamification approach in order to enhance and encourage people to improve the data, which is continuously done. Basically, the feedback, and Jean mentioned some of the examples, and the way we do it is providing a completeness score for each of the data records in the DIMES system, a list of potential issues which might be addressed, so the information and the data can be corrected, and also using a color scheme in order to make it easier for the users to address. So overall, we tried to implement these recommendations of the data management principles. We think site information is an important part in the documentation chain for in situ data. So this, I think it's also interesting for the Earth observation community to find dedicated sites where data are available. But it's also important for the ecosystem and biodiversity observation community to provide information on the context. And with that, I thank you for the attention, and I'm open for any questions.
Thank you very much, Johannes. A very inspiring example. I'd say I'm covering quite well each of the different principles. I would like to hear from the audience. Do you have any questions for Johannes? Don't be shy, write in the chat or raise your hand if there are anything that you, yeah, Marie-Françoise?
Well, yes, thank you, Johannes, for showing that standards are enablers to meet this usability. You have mentioned that DAME SDR has been improved with in time and specifically with eShape. Do you have some analytics on the use, the real use? Because we talk about usability. But then you say that you have different types of publication with different standards and so on. And do you have analytics to show which are the best standards or publication to reach the real users? So based on the use statistics.
Yeah, basically what we don't have at the moment is to really have the use statistics. So basically we deactivated this because of the data protection regulations. We had that early on, but nevertheless we have discussions with the potential users of the system, and basically it's the most used interface at the moment is the REST API, because it allows really this machine-to-machine communication, and especially and you know, one of the examples we had in eShape was this crocodile. So this cropping of the Sentinel tiles to provide information on available remote sensing information, and also in the ELTA context, a series of applications was developed, for example, to extract information from third-party data sources, so namely from GBIF or a natural list, or also from FluxNet, and basically in all of the cases, the REST API with the JSON encoding was the most used interface and standard. Yeah.
Okay. Yes, because I think it will be at some point we work on making data more usable, but it would be interesting to really check if it is used.
Yeah.
And then I was, and thank you very much for showing that licensing is also something that can increase the usability, publishing a clear license.
Yeah.
This is something we have a little bit talk about at the start, but it could be, I think, also enhanced into the principles as a way to make data more usable.
Yeah. And it's also here for the, you know, what we are dealing in this long-term observation network for ecosystem and biodiversity. Is basically we are dealing with different levels of information, and basically what we normally show it as a kind of a pyramid, and on the top of the pyramid, you know, there is the information on the site, where also licensing is a bit easier, and also the timely provision of information. When it comes to the real in situ data, that's a part we are also, you know, step by step dealing. So we address it in eShape, but it is also addressed in the ELTA context in order to enhance and mobilize in situ data also for the Earth observation community, and there the licensing aspect and providing an open license and the timely provision is a very important aspect.
Yeah.
Not easy to be discussed, and there it comes back to the point, Bente, where you introduced that data management is a burden, and when it comes to in situ data, and especially when it comes to legacy data, sometimes it's really a burden because, for example, in terms of LTR, we are talking about data, starting in the early 90s or even earlier, where still a lot of information might be in formats which can be easily transformed, or we come exactly to the situation which was addressed by Jean, where in theory, you have information on how the observation was done, but for example, the observer already died or retired or whatever. So that could be quite time consuming. There is a very nice example from the LTR Italy network, where they tried to harmonize or tried to mobilize data from the northern Adriatic Sea, and they really invested quite a lot of times to go back to the original observers to try to get the information. And it's a burden, it's a time-consuming process, but in the end, it really pays off because these long-term data sets are really a great value we have also on the European scale and from our network, and also I think also important in the geo context.
Yeah, so just recognizing the importance and the value of the data, you say, I think that's the first step. And then you have to recognize also the cost. It's not only the time, but actually resources. Somebody has to do some work, and it's not for free. I mean, so I think this for the funding agencies to be aware of the cost that is required to this type of job, I think is one of the things that we could try to communicate, both the value and that it pays off, as you said. I have one small question on the licenses again, because you are a governmental agency, right? The Environmental Agency of Austria. And I assume that you are then obliged to follow the INSPIRES, so you make the data transnationally accessible. But how about, and it was something with the commercial licensing. So we are also talking about creating value for, to grow the market on commercial actors. I wasn't quite sure if that was allowed with your data or what.
That's a very good question. In the end, it's not our data. We are just providing the service for the international LTR community to document the information. And basically, it was an agreement in the community to put that license on top of it, because that is also the recommended license for ELTA data in a way that might change in future. But at the moment, it's a community agreement. So that's the point.
That's the point. Yeah. So I think we are bringing up some issues, some topics that to be discussed further with respect to usability in a broader sense. So thank you so much, Johannes. I don't see any more questions. Do I have a comment here or not? I don't see that. Well, or maybe. Yeah, it's always an investment in time, Paula says. So now talking about Paula, Paula, I'm about to give you the floor, and you will introduce us to the Geo Knowledge Hub. So, but before I would like to, even though I'm sure many know you here, I would like to introduce you to the audience. It's not Johannes, it's Paula De Salvo. She's Italian, and she has a master's degree in environmental biology from University of Roma. She's been involved in GIS and remote sensing for a very long time, including in the agricultural. I will give you the access, Paula, just while I'm introducing you. And we have also been involved. Oops, what is happening here?
I can very quickly go through it, Bente.
You are on my document, weren't you not?
I suppose.
Yes.
Okay, so well, in a nutshell, I'm in the geospatial domain since 20 plus years, mainly within the UN organization, FAO and World Food Program. A few years with ESRI in the private sector before joining GEO and advocating for open data, open knowledge. So it is my pleasure to be able to talk to you today about the Geo Knowledge Hub and how the Geo Knowledge Hub is leveraging the. Sorry, Bente, you are taking my screen or not?
No, I think we might have been hacked somehow, because there's some unfortunate actions on or writing in the chat, and
Yes.
when yeah, so somebody is having fun.
Account. Okay, so we shall switch off our computers.
Yes, very quickly, and come back to this again afterwards.